This is the review for your first test of the year on data and statistics. You'll typically receive the review packet with one night to work on your own, which doesn't mean you should try to finish the review. You can't really do it the whole thing in one night, but it gives you a chance to preview and try some of the problems on your own and bring it into class the next day, where we'll begin what is typically a 2-day in-class review. And so it benefits you to have previewed the problems and try them on your own. You shouldn't expect to be able to do every single problem. I designed the review to be very challenging, and so don't be alarmed if there are some problems you cannot do at first. We'll work on the review in class together for 2 days, and you should be watching these videos after you've tried the problems on your own. There's one video for every single page of the review. Unlike the support videos for your learning opportunity assignments, you're not required to watch the entire video for the test review. Maybe there's a particular problem you're concerned about, and maybe you fast forward to that problem, and they can help you study in that way. Don't forget to get your test review signed by your parents. It shows your parents that you have an important upcoming test, and they can see that you've worked hard to prepare for that test by getting the review signed, and that will give you 2 bonus points on the test if you get it signed. We'll begin our test review with problem 1 right now. This is problem 1 on the first page. The circle graph shows the results of a survey of 240 people who were asked about their favorite breakfast food. About how many people answered toast. If I look at this section of the circle graph that's toast, I could come up with some reasonable estimate for what percent that is, but I also have a nice reference. If you look at toast and other together, if you sort of focus on these 2 categories together, you see that they're pretty clearly one quarter of the circle, because this is a 90-degree angle right here. And so it's a helpful reference because 1/4 of the circle would be 25%. And so how much of this 25% do you think toast makes up? It's almost all of it. So any estimate close to 20% I think would be a good estimate. So if you use 20%, I think that's good. Anything close to 20% would also be fine. I'm actually going to take anything from about 15% to maybe 24%, just because it's a little bit subjective without measuring. But 20% is probably the most reasonable estimate. So 20% of the people, 20% of 240 will be a good estimate for the number of people that answered toast. And then this is just like some of the percent problems we've been doing on Computation Go. Some of you like to set this up as a percent proportion. 20% is how many 240ths. I prefer when it's just a percent of some amount to realize that an amount of an amount is multiplication, and so you could just represent 20% as a decimal, standard form, 0.20 multiplied by 240. And then, of course, 0.20, 20 hundredths is the same as 2/10. I could set up a multiplication algorithm, but it's not really necessary. All I'm doing is doubling the 240, which is 480, and then realizing that I was multiplying tenths times wholes, so I should have tenths as my answer. I should have 1 decimal place in my product. And so 48 people. Now, always consider whether your answer is reasonable. We said that toast was a little less than 25%. 25% of 240, 1/4 of those people would be 60 people, and 48 is just a little bit less than 60, so this seems like a reasonable answer. We should include our units, of course, 48 people. The pen gets away from me. I'm not exactly sure what does that, but yeah, 48 people, so circle your answer. Problem number 2 on the review is a stem and leaf plot. And we know from the key that a 6 with a 6 as your stem and a 2 as your leaf represents 62, so these are tens. The stems are tens and the leaves are the ones digits. This is called a quantitative comparison problem, and you'll see these on the ERB test. You'll also see them on the SAT test, so it's good practice to get used to this format. I'll always put 1 or 2 of these on your test reviews and also on your tests. So we're comparing these quantities. We're comparing the mode to the median for this set of data. And then the multiple choice answers will always be the same. You're either going to answer that A is greater than B, or B is greater than A, or sometimes they'll be equal, A is equal to B, or sometimes there's not enough information to tell which one is greater. So here we're comparing the mode of this data to the median of this data. So if we find the mode and the median, we should be able to definitely answer. So I don't think D will be a correct answer. We'll just have to see whether one is greater than the other or whether they're equal. The mode is easy to spot in a stem and leaf plot. That's one of the advantages of a stem and leaf plot. It's just very similar to the advantages of a line plot. Your data is ordered from least to greatest in a condensed way, in a graphical format, so that you don't have a very long list of data. But you can also just do, with data, you can always just list at least to greatest to make a list, and then you'll also be able to easily spot the mode, find the range, locate the median, etc. That's true on a stem and leaf, a line plot, and actually to some extent also on a scatter plot. You can see very easily spot the high and the low. You could work your way toward the median, and you could find the mode of your data. So on this stem and leaf plot, if I'm looking for the mode, I'm looking for the leaves that occur the most, because, for example, this leaf represents 62. Here I have 63. They each occur once. I see here that 74 occurs twice, so that might be our mode. These occur once. 91 occurs 3 times, and that's more than 74, so 91 is the mode. As soon as you find the quantity that matches the box, you should either write it in the box or very close to the box. It's very helpful once you have it down to a value when you do the comparison. The median, we're going to cross off a low value with a high value. And I'm not scribbling them out. I can still see the numbers in case I make a mistake and I want to go back. So the next lowest, the next highest, 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 the next lowest, the next highest. So 83 is in the middle, 83 is the median. We could have kind of told that just by looking at where the 91s are, right? We know that the 91s are within the first 5 highest values, and there's many more than 5 lower values. So we knew the median was going to be less than the mode. So in this case, A is greater than B, so we'll choose answer choice A. Problem number 3 is a question taken directly from SAT test preparation materials, and I think it's pretty exciting that a high stakes test like the SAT test that you'll take in your junior year of high school as you're preparing for college is well within your range of ability already in 6th grade advanced math. So here we're going to use quite a few of these. This one says the average of a set of 8 consecutive odd integers. We'll need to know what these words mean. Integers also. The average of a set of 8 consecutive odd integers is 18. So the average is the same as the mean. What is the greatest of these 8 integers? Integers are whole numbers and their opposites. So 0, 1, 2, 3, 4, 5. The opposite of 1 is -1. So it's basically counting numbers, 0, and the opposites of the counting numbers. So we're not dealing with any 1.7 or 3 2/3, anything like that. Odd numbers are not divisible by 2. Divisible meaning you get a whole number quotient, and consecutive means in a row, adjacent to each other. So let's not go straight after the answer just yet. Let's just look at some consecutive odd integers. 1, 3, 5, 7, 9. There's just a few consecutive odd integers. The average of these consecutive odd integers is equal to the median, because this 7 is 2 higher than this 5, and this 3 is 2 lower than this 5. The 9 is 4 higher, and the 1 is 4 lower. So these all balance out to be 5. If I took 2 away from the 7 and gave it to the 3, they would both be 5s. If I took 4 away from the 9 and gave it to the 1, they would both be 5s. So when you have consecutive integers, the median equals the mean. And so if they tell you that the average is 18, 18 is the median. So you can just start with 18. It's not odd though. So that tells us something interesting also. Let's just look at a number line. I always forget that I have a straight line function on this. Let me try to take advantage of it here. Okay. 18 is going to be in the middle of our odd integers, but 18 itself is not odd. So that must mean I have odd integers adjacent to 18, like 17 and 19. Okay, those must be my two middle numbers in this set of 8 consecutive odd integers. The next lower odd integer below 17 would be 15. And the next higher one after 19 would be 21. So this makes sense because 19 is 1 above 18 and 17 is 1 below. 21 is 3 above 18, 15 is 3 below. So I just fill in the rest of these: 23, 25, 13, 11. And there are my 8 consecutive odd integers. And I know that if I took 1 here and put it here, they both would be 18. Take 3 away from 21 and give it to the 15, they would both be 18. Take 5 away from the 23, it becomes 18, and put those 5 right here and that becomes 18. So they all can balance out using that conceptual understanding of the mean as all the data being the same. We can see that these would be our 8 consecutive odd integers, and then we can easily answer the question, what is the greatest of these 8 integers, by just finding the greatest one, 25.
Problem number 4 is a good problem for checking whether you understand the concept of mean or average conceptually. It says 10 friends have an average of 3 yo-yos each. Christian joins them, and now the mean is 4 yo-yos each. How many yo-yos does Christian have? So if we do a little, let's just visualize this first. The first friend has 3 yo-yos, the second friend has 3 yo-yos. Actually, they probably don't, right? Friend number 1 might have none, friend number 2 might have 6, and they balance out to 3, they average out to 3. We don't know from the problem how many any of the 10 friends have. But we know that if we took the total number of yo-yos that the 10 friends have and divided them equally among the 10 friends, they would each get 3 yo-yos. So that's really what I'm showing here. And I'm not going to show all 10 of them, but you get the idea. If you imagine each of the 10 friends has 3 yo-yos, then you can use that to understand that the total number of yo-yos would be 3 multiplied by 10, or 30. But then Christian joins. He'll be the 11th friend, because there are 10. I'm not going to show them all, but 10 friends, and then he joins. And then he has so many yo-yos that the average actually raises from 3 to 4. So he must have a lot. I mean, he has to have at least 4 for the average to be 4, and then he has to have enough extra so that he can give each other friend one of his yo-yos. Because each one of them have to increase their number of yo-yos by 1 in order for the average to raise from 3 to 4. And even after all that, he still has to have 4 for himself. So he needs to give each of 10 friends 1 yo-yo, so that's 10 yo-yos. Plus he needs to have 4 for himself, so he needs to have 14 yo-yos in order for that to be true. The other way to think about that is if the mean was now 4 and there were 11 friends, the total number of yo-yos would be 44. So there were 30 yo-yos before Christian joined, and there are 44 yo-yos now, so the difference would tell you how many yo-yos Christian had, which would be a total of 14. Okay, I hope that helped with page 1. We'll continue the review with page 2 on the next video.